SwayamPrabha. Digital India. Educated India.
Good morning. Welcome to this lecture for the online course on sustainable architecture. And in the previous lecture, we were discussing about the tools for understanding the response of the building to the given climatic context. And there we had talked about the bioclimatic chart, and we learned how to use Mahoney's table to identify the appropriate design strategies for the given climatic context, which was based upon the understanding of air temperatures, humidity, rainfall and wind data. Today, before I move on to use another tool, we would very quickly understand the design strategies which were suggested through Mahoney's table. So, let us quickly look at those passive design strategies which are proposed in Mahoney's table, go over each of them one by one. So, the type of passive design strategies that we are looking at are building orientation, plan form, design elements, roof form, fenestration, where we are talking about arrangement, configuration and orientation, all of these, roof and wall materials and vegetation. Starting with building orientation first. So, the building orientation mainly determines the amount of radiation which the building is going to receive. Since we very clearly know that the sun moves from east to west in the northern hemisphere, we are talking about India in this case. So, it rises from the east and sets down in the west. So, predominantly this is how the sun path is going to be. So, an orientation where the north-south axis is larger, which has more exposure towards east and west, is not preferable for hot climates, and large part of our country has warm, hot or tropical climate. So, this orientation is not preferred. Also, the reason is because when the sun comes to the south, it is at a very high altitude and the solar radiation can very conveniently be cut off by using horizontal shading. So, it is always preferable in hot areas to have your building oriented in such a manner that it has a longer east-west axis. Here, when we are talking about building orientation, it automatically affects the orientation of the street. So, if we have more buildings oriented with their longer axis in east-west direction, we automatically know that we have streets which are in the north-south direction, and in such a case the streets also remain shaded for most time of the day. So, the preferable street orientation is north-south, which facilitates the buildings like this, and it helps the streets to remain shaded for large part of the day. Now, we are talking about the plan form. When we talk about various arrangements for plan form, we are talking with respect to certain parameters. One, we are talking about the airflow around the building plan and through it. The second thing, we are talking about perimeter to area ratio. Perimeter to area ratio also leads to surface to volume ratio, not exactly the same, but directly proportional. So, we are looking at the perimeter to area ratio because it is an important indicator of the heat transfer. It could be loss or it could be gain. So, these are the two reasons because of which we talk about the plan form. Now, when we are talking about the hot or cold climates, we should reduce the perimeter to area ratio to minimum so as to ensure minimum heat transfer, because larger is the perimeter, larger would be the surface area and more would be the surfaces available for heat transfer. In warm humid climates, for on the other hand, we should have larger perimeter to area ratio, because larger is the surface, larger is the possibility for heat transfer and air movement, air ventilation. From this perspective, if we look at different plan forms, we would see that the best plan form which is suited for minimal heat transfer is a circular form. And that is why if we look at majority of the traditional building plan forms in hot dry climates, we would find that they are often circular. You look at bungas of Rajasthan, you look at huts from Cameroon, huts from Kutch, we would find that they are usually circular in plan. That minimizes the perimeter to area ratio. The optimum one is a square and a building plan form which has a lot of wings coming out and a lot of penetrations, a lot of punctures in the plan form will result in a building which has very large perimeter to area ratio, and that kind of a form would be suitable for a warm humid climate, and these ones for hot and cold. Next we come to the design elements. When we are talking about design elements, we talk about the water bodies, where should they be placed. We are talking about vegetation. Now each of these design elements has impacts on temperature, on humidity, on air. So vegetation can absorb radiation and it can affect cooling, it can also channelize the air. Similarly, water body, if it falls en route, the air from where the air is entering into the building in the direction of wind, it can pick up, the air can pick up humidity, moisture from the water body and add to the moisture. So in a hot dry climate, a water body planned in the route from where the wind is entering the building is preferred, while in a cold climate it may not. Then we are also looking at courtyards and verandas as design elements. Now courtyards and verandas are required, are used for shading, for cutting off the direct solar radiation in buildings. So they are more preferable in hot dry climates. In warm climates, courtyards and verandas also facilitate movement of air because of the differential heating, because of the shading which is there. So the indoors remain cool, the verandas and courtyards are at a moderate temperature and the outdoors are at a higher temperature. So it induces air movement because of this differential heating, and that is why verandas and courtyards are also the highly preferred design elements for warm humid climates, because it induces the air movement. They help in absorbing, so we are looking at vegetation, it helps in absorbing radiation. In case we are looking at water body, it stores the heat during the day and it releases it at night. We can also combine the vegetation along with a greenhouse. We are looking at courtyards and verandas which help not just in shading and but also ventilation, which is what we just discussed about. Besides the air movement and solar radiation and controlling the air temperature, these elements also help in controlling the daylight. Suppose we plant deciduous trees towards south. So in summers, these deciduous trees would shade the building and control the direct radiation and also the daylighting, while in winters when they shed their leaves, they allow a lot of sunlight and daylight to penetrate inside the building. So together these elements control a lot of environmental parameters. The next we are looking at roof form. So if we have a flat roof, it gives maximum exposure to the solar radiation. It is exposed for a longer duration of time because it is flat and receives sun almost throughout the day. While if we have domical roofs, half of the dome would at any given point of time be shaded. by its own. Same as with walls if it is properly oriented. Now, for this reason you would always find that in extremely hot climates domes are the preferred roof form. So, it is not by chance that the use of domes was more in the Middle East and it evolved from there. It was the necessity which led people to understand, to realize, research that dome is the most preferred form. Besides the direct solar radiation, it has also to do with the amount of precipitation which is received. So, if there is very high amount of precipitation, the sloping roof is preferred. Of course, that is a very common understanding. So, domical roofs are good for areas where there is very high amount of solar radiation, but we want to cut it off. Sloping roofs would be good for cutting down on solar radiations partially and also to facilitate managing the rainwater, heavy rains, and flat roofs are good for cold areas because we want maximum amount of solar exposure onto these roofs. That is why in majority of the cold climates either we would find roofs sloping where the exposure is largely towards the south, or we would find flat roofs where in cold climates where there is no precipitation or very less precipitation, we would find flat roofs. So, in Leh, Ladakh, Spiti Valley which is cold dry, we would find these cold flat roofs in cold regions, while in the northeast states where it is cold and humid, where the rain is also there, we would find sloping roofs, and in Rajasthan, in extremely hot climates where we would find structures such as bungas, we would find these domical roof forms. Next we talk about the arrangement and configuration of fenestration. Now, fenestration in today's times becomes one of the most important element of building because it affects the movement of air and hence the temperature indoors. It allows for light. It also controls the amount of air which is coming in and going out, so controls the ventilation requirement. If we look at the physiological objective, in extremely hot and cold climate, we do not want an interaction of the outdoors with the indoors as far as heat exchange is concerned. So, in both these climates, hot, dry and cold, we would prefer smaller windows, very small windows where not much of heat exchange through convection is happening. That is what windows facilitate, fenestration facilitates. However, in warm humid climate, we would want a lot of air movement to happen because that is what brings in the comfort. So, in warm humid climate, the size of the fenestration is preferred to be large. So, huge openings are preferred in warm humid climate. Now, when we are talking about hot, dry and cold climates, the kind of material that the fenestration should have will also matter. So, if we have insulated glass, clear glass, double glazed window which allows a lot of radiation to come in but blocks the air, that would be preferred in cold climate. So, fixed glass windows which will allow a lot of sun to penetrate in. So, the window should be oriented towards the direction of the sun. So, south facing windows and also inclined at a certain level so that a lot of sun can penetrate in. That is an ideal arrangement in a cold climate. However, if we look at hot climate, we do not want direct solar radiation, we do not want a lot of daylight because it is anyways very clear and bright. So, very small amount of opening would do, and we also do not want any air movement. So, in hot climates traditionally you would find wooden shutters. So, wooden shutters would control all these three. That is how the fenestrations have been designed as far as the material is concerned. If we look at the arrangement determines the amount of airflow inside the room. So, if you look at SP 41 where a lot of arrangements of windows have been proposed, this is in plan that we see. So, if we have windows arranged in opposite corners on opposite walls of the room, it will allow almost the entire room to ventilate properly. However, if we do not have these windows, these openings, the wind would just not circulate through the entire room. So, for enhancing the air movement, it is preferable, it is advised that the windows be provided on, the openings be provided on the opposite walls and preferably the corners, so that the entire room remains well ventilated. When we are talking about the orientation, as I have just talked about, the southern glazing which is oriented towards south would maximize the heat gain, and hence it would be preferred in cold climates. While if the window is towards east and west, it would maximize the heat gain during morning and evening. At that time, morning and evening, the sun might be at lower temperature, especially mornings, not necessarily evenings, but we must also keep in mind that it is extremely difficult to shade these windows because of the low altitude of the sun. So, if we are providing windows in east and west, in most likely cases the sun would penetrate inside the building. So, the windows have to be properly oriented, the fenestration has to be properly oriented in order to control. In addition to designing the size, orientation and arrangement of fenestration, we can also add controls of fenestration along. So, we have different types of controls that we can take into account. One most common and popular is shading devices. Shading devices could be both horizontal and vertical, and I am sure in your climatology you have already read about the sun path diagrams and how to design shading devices, how to understand the movement of sun and how to cut it down using horizontal devices as well as vertical devices. Now, in today's times, these shading devices are of multiple types, not just the fixed ones. We have moving ones, we have the outdoor ones which are moving, we have the indoor blinds which are moving, and so on. In addition to that, we have light shelves. Now, light shelf is a very interesting concept where above the window, so this is the window, and above it we have a shelf which is a permanent feature where the light is, and the upper surface of this light shelf is quite reflective, very light in color. So, the light which is falling onto this light shelf is reflected to the ceiling, and this ceiling is also maintained at a very light color, is also light colored, and this further diffuses the light inside. So, this is a light shelf where the direct glare onto a work surface is cut off, and diffused light and it is penetrated deeper into the room. So, light shelf is very good for distributing the light and in a diffused manner without causing any glare to a bigger area, to a larger area of the room. In addition to that, we also have windows which are recessed. So, there is shading all around. So, there is a box type of shading and it helps to cut down on direct solar radiation. We can also have minimal shades, they also help in controlling the rains and at the same time in shading. So, depending upon the orientation and the sun path diagram, these shading devices can be designed. Next, we come on to wall materials. Now, depending upon the physiological objective, if you very clearly remember when we were talking about the hot, dry and cold climates, there we want less and less of heat transfer to take place. In order to do that, we have to have very high thermal mass, so that in extreme summers, this thermal mass is able to store the heat which it receives from outside and not transfer it inside, while this same heat which is absorbed during the extreme summers is further released during winters, that is seasonal variation of the structure. Along with that, there will also be a diurnal variation of the structure which results in what we call as time lag. So, what we normally find in traditional structures in hot dry climate is that there is a heavy thermal mass which absorbs heat during the extremely hot period of the day, say extreme noon, when the temperature is around 45-43 degrees centigrade. And during the night, when the outdoor temperature has fallen down to a comfortable range and people can spend their time outdoors, that is the time when the structure releases the heat that it has absorbed to the indoors, and that is the time when the indoors will be flushed out throughout the night and the heat can be released from the structure to the outdoors ambient environment. So, depending upon the physiological objective, the materials for the wall will be selected. In hot, dry and cold climates, we would want to use materials which have heavy thermal mass, which can store a lot of heat. In warm humid climates, because it is anyways very humid, we would want very light materials. We do not want these materials to store heat, but we want these materials to allow the ventilation of air. And this is the basis which we use to select wall materials. The quantity, the terminology that we use here for understanding the property is U value. It is the amount of heat which is transferred from one surface to the other surface at a unit degree temperature change from a unit area of the wall or surface. Higher is the U value, higher is the rate of heat transfer. Lower is the U value, lower is the amount of heat which is transmitted from one side to the other side. So, in hot, dry and cold climates, we would want walling materials with a very low U value. Now, any insulation material for that matter has a low U value. So, in hot and cold climates, we want to use insulating materials. That is why you would have seen that in extremely cold countries, we have walls which have insulation material packed between the walls. Now, this reduces the heat flow from one side to the other, because the diurnal variation and the variation between indoors and outdoors is extremely high. I am talking about the temperature, say outdoors is minus 25 degrees centigrade and indoors for comfort you want to maintain around 20 degrees centigrade. So, we are looking at a temperature difference of around 40 degrees centigrade from outdoor to indoor. Now, if I provide an insulation material in the wall, also roof, there I will be able to cut down on the transfer of heat from indoor to outdoor in this case. The same concept holds good for the roof, exactly the same, where we want thick materials with heavy insulation capacity, low U value for hot and cold climates. Another design feature which we have already discussed, but here we are discussing it with respect to the air movement, is vegetation. Now, the vegetation diverts the wind, the air into the building or away from the building depending upon how we plant it. If we are planting huge trees or if we are planting small shrubberies, will guide how the air is diverted into the building or away from the building. To summarize what we have discussed so far, we can put the strategies for passive heating, passive cooling, passive ventilation and daylighting into groups, in these groups. So, if we are looking at the passive heating strategies, we would look at orienting the building in such a manner so as to increase the heat gain, the building shape, the plan form such that it has a lower perimeter to area ratio. We have to create buffer spaces and double facades such as the greenhouse, where the buffer spaces are the ones which interact with the outdoors and store the amount of heat which is received during the day and gradually passes it on to the indoors. The spatial planning, here in current times the material of the fenestration such as high performance glass, the low E glass is also preferred. If we are talking about the active side of it, we may talk about the heat recovery ventilation, where before it is ventilated out, the air is ventilated out, the heat is recovered from the exhausting air. Low window to wall area ratio, where we are talking about the small size of the openings, and high surface to volume ratio. We are talking about the operable external shading as a passive heating strategy, because in winters we would want more sun, solar radiation to come inside the building, but not during the summer season. High thermal mass, and we have to minimize infiltration, especially during the cold season, cold period. If we look at the passive cooling strategies, we may again go for operable external shading, but in a hot climate, fixed external shading would also work fine, because for most part of the year the climate of the place is warm, it is hot. The thermal mass similar to cold climates, low window to wall ratio, passive ventilation, and induced ventilation in case of hot dry climate is highly preferred. Nighttime cooling, which I was mentioning as a night flushing or night purging, stacked windows, window above one another, evaporative cooling in case there is availability of water. So, in case of traditional architecture of the Middle East, we would find wind towers and barriers which are fitted with water sprinkling equipment, such that when the air comes in through these wind towers, it is cooled evaporatively, and it is also humidified before it enters the indoors. And in earth tempering ducts, we are talking about the earth air tunnels, which take the advantage of the ground temperature remaining at a constant. Then we are talking about the passive ventilation strategies. Here we are talking about the operable windows, which is becoming more and more scarce, rare in case of air conditioned and commercial buildings. We do not have operable windows, while we must have operable windows in order to facilitate passive ventilation. Again, buffer spaces and double facades, the shape of the building in order to divert wind inside the building, vegetation, spatial planning and orientation, all in order to divert wind into the building, forced ventilation. Then strategic architectural features such as vegetation, opening to corridors, central atrium, which is one of its kind is courtyard, which is open to sky, and wind towers. Wind towers are often a very interesting means of inducing passive ventilation. For daylighting, we have to look at how the space is planned. We have to look at high ceilings when they are paired with tall windows. In such case, looking at light shelves, skylights and light tubes. Skylights are often very good means of bringing in daylight to deeper areas. Clear stories in factories and a lot of industrial buildings, we find a lot of clear stories being used. And here when we are talking about daylighting, we look at the interior surface colors and finishes, and some of the strategic architectural features such as planting deciduous ventilation, vegetation. I will stop here for this lecture, and in the next lecture we would talk about the software which is called Climate Consultant. So, when you look at the next lecture where I work upon Climate Consultant, you should have the Climate Consultant software. It is a free to download and use software available online. You can download it, install it on your systems when you look at the lecture, when you listen to my lecture, so that you can work hands on the Climate Consultant software. Thank you. See you in the next lecture.